Question 1. In this question, the design of a strip footing installed in stiff clay is considered under two conditions, which is short-term condition and long-term condition. These two conditions decide how we select the format of the strength parameters of the soil. For short-term condition, we use total cohesion, phi angle, unit weight, and for long-term, we use effective cohesion, phi prime, and a gamma prime. And we have a important statement that the groundwater level is 10 meters below the ground surface, which means it's deep, so that we don't need to consider the impact of groundwater on the calculations. With these decisions, we can proceed to the equation 10.1 from CFEM. To start the calculation of the ultimate bearing capacity QU. This equation says that QU is equal to a cohesion term C times NC times SC plus the QS term times NQ times SQ, and plus the unit weight term 1/2 times B, which is the width of the strip footing, times gamma, the unit weight, and N gamma times S gamma. This equation is valid for both total stress approach and the effective stress approach. For the short term, this C SCU for short term, and it's C prime for long term, and a QS is equal to the vertical total stress at the bottom level of the footing in the soil for short-term design, and sigma V prime at the same level for long-term design. And the last term, gamma in this equation, and gamma times this gamma. The determination of this gamma is gamma for short term and gamma prime for long term. And then we can turn to these factors included in the equation. In this equation 10.1, we have two series of factors, NC and Q and gamma. These N factors are called bearing capacity factors. We can use phi or phi prime. through table 10.1 to find these three factors. For total stress approach and the cohesive soil here in this question, phi is equal to 0. And we have second series of factors, SC, SQ, and S gamma. These three factors are called the modification factors. They are used to correct the conditions of the ground, conditions of the load, and conditions of the embedment depth or dimensions of the foundations. You can use B, which is the width of the footing, L, length of the footing. Here for the straight footing, this L is a very large value, and D is the depth for the straight footing. And through table 10.2, you can determine these three S factors. Notably, when you need to use B over L ratio in this evaluation or assessment for strip footing, you have to assume this ratio to be 0. Then the calculation of QS for short term. Use gamma times D, and for the QS under long-term condition, we use gamma prime D. However, since the groundwater is not affecting the unit weight or the vertical stress in the soil near the ground surface, so this gamma prime is equal to gamma. Then let's try to answer part A. What is the factor of safety in work stress design? In work stress design, we have this equation to state the relationship between Q allowable, which is the allowable pressure to be applied, and Q net U divided by factor of safety plus Q over burden, and Q net U is equal to QU minus Q over burden. QU is the ultimate bearing capacity you calculated from equation 10.1, and Q over burden is equal to QS for this question. Then we can easily find the factor of safety. And part B, for the factored geotechnical resistance, phi Rn using LRFD, we need to know phi factor for shallow foundations is usually selected to be 0.5, and Rn, geotechnical resistance, is equal to the QU you calculated previously.